back to Science Fantastic with Professor Michio Kaku. Today we're going to talk about a new IMAX film that's hitting your Cineplex. It's called Asteroid Hunters. Not only does it have all the Hollywood special effects that we're accustomed to in these big productions, but it's authoritative. Professional astronomers consulted for this new IMAX film. And we're going to bring on our special guest in a few minutes, Dr. Donald Yeomans. He's the author of a new book, Near-Earth Objects. In other words, asteroids that cross our path. Finding them before they find us. Now, of course, Hollywood has pretty much brainwashed us into thinking that Bruce Willis is going to come to the rescue if a killer asteroid is headed our way. But what about the science, the real science behind this? But today, we're going to go right back to the planet Earth and talk to Dr. Donald Yeomans, author of the book Near-Earth Objects, Finding Them Before They Find Us. He's the principal science advisor for the IMAX film Asteroid Hunters. So, Dr. Yeomans, tell us a little bit about your youth. When you were a young kid, what steered you in the direction of science and eventually astronomy?
Well, I think I was always interested in science. Like many young folks, I had my own little chemistry set so I could venture into chemistry. But then my father bought me a small telescope for one Christmas, and that really got me started into astronomy. And so I got some newsletters and magazines, Sky and Telescope, Astronomy Magazine, Scientific American, so it just sort of snowballed after that.
Okay, now your book is called Near-Earth Objects, NEOs. Can you tell us what are they?
Well, near-Earth objects are primarily asteroids. They can get within about 30 million miles of the Earth's orbit, and there's a subset of near-Earth asteroids called potentially hazardous asteroids that can get within about 20 lunar distances of the Earth and hence could be perturbed by gravitational attraction of a neighboring planet into an Earth collider. So it's primarily the potentially hazardous asteroids that we're concerned with.
Now, some people say that it's a distant threat. We don't have to worry about it. When scientists go to the United States Congress and ask for money to get an early warning system for these near-Earth objects, most congressmen and congresswomen simply exhibit the giggle factor. They simply giggle at the scientists and deny us much funding. But what about real incidences now? What happened in Russia? What happened in Russia near Chelyabinsk a few years ago? And what happened in Russia in Siberia in 1908 in Tunguska?
Well, in 1908, and as you said, in Soviet Siberia, there was an impactor about 40 meters in diameter that impacted in a very poorly populated area, fortunately. So it set off an explosion because of the way that the object came into the Earth's atmosphere. There was more pressure on the front side than there was on the back side. So it sort of pancaked and exploded, knocking down trees for many miles. And it was such a remote area that it took several years for scientists to get in there and examine what exactly happened. And the most likely explanation is an asteroid impact that occurred back in 1908.
Now, I understand that it also created a bang, a huge noise, one of the largest noises that people have ever heard before. But that noise was heard for miles, right?
Yeah, the shockwave what is the noise, as you mentioned, was actually recorded in seismic instruments around the globe. So the impact itself was noted in seismic instruments around the globe, although it wasn't attributed at the time to a near-Earth asteroid. That's what it turned out to be.
Now, if that object had hit London or Moscow, what kind of damage do you think might have happened?
Oh, it would have wiped out the city. Fortunately, where it hit in Soviet Siberia, there was very sparsely populated. In fact, there was no fatalities. A lot of the native animals were wiped out, of course, and one gentleman at least was knocked off his porch. but fortunately it was so underpopulated that there wasn't any fatalities. But had it hit over a city, it would have wiped out the city completely.
Now, compare the 1908 incidents with what happened just a few years ago, again in Russia near Chelyabinsk.
Yeah, that was the event that occurred on February 15th of 2013. A 20-meter object this time, smaller than the one in Tunguska, came in on February 15th, came in from the direction of the sun. So it wasn't initially observed by telescopes that are, of course, required to look in the nighttime sky. So this Chelyabinsk fireball sort of took us by surprise. The air blast amounted to about 470 kilotons of equivalent energy. And fortunately, there was no fatalities. But what happened is that it exploded high in the atmosphere, and then the shock wave broke many windows in the town of Chelyabinsk, and people who had run to the windows to see what the flash of light was all about were hit with flying glass. So some 1,500 folks were injured as a result of flying glass.
Now, in the United States, we don't have any recorded incidences of these things, but when you go back thousands of years into the past, and you go to Arizona, we have the Meteor crater. So tell us a little bit about the Meteor crater and what kind of object created it.
Yeah, Meteor crater near Winslow, Arizona is a tourist attraction now. It was actually created about 50,000 years ago when an iron asteroid impacted the Earth and created a crater that is the better part of a mile in diameter. It's quite an event that took place, but again, that was 50,000 years ago, and it was formed by a fairly rare type of asteroid that it was solid iron. And there was an attempt to actually locate the iron asteroid and mine it for the metal content, but the impact itself completely destroyed the iron meteor, and the only fragments of the iron meteor remained as meteorite.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Dr. Donald Yeomans. He is the principal science advisor for a new IMAX film hitting your Cineplex. It's called Asteroid Hunters. It has all the Hollywood special effects. Not only that, it is authoritative. A team of professional astronomers were advisors to that IMAX film, Asteroid Hunters, so watch for it. And our special guest today is Dr. Donald Yeomans, who was the principal science advisor for that IMAX film, and he's the author of his book, Near-Earth Objects, Finding Them Before They Find Us. So, Dr. Yeomans, tell us now about what happened in Mexico, in the Yucatan, 65 million years ago, that changed the destiny of life on the planet Earth.
Yeah, this is an event that took place, as you noted, 65 million years ago, when an asteroid, this time 10 kilometers, or about 6 miles in diameter, impacted the Earth and caused a crater off the so-called Chicxulub crater off the Yucatan Peninsula. There was 50 million megatons of equivalent energy, so it was a huge explosion that threw dust and debris into the air, shut down sunlight for months at a time, and so the plants that depended on sunlight for growing were killed, and the animals that thrived on these plants, especially the large ones like dinosaurs, were wiped out as well. So a fair fraction of the Earth's animals were wiped out at this time, as was much of the vegetation that these animals required to survive. So that was an event that was caused by an object 6 kilometers or 6 miles in diameter, and you wouldn't expect an object of that size to hit but every half million years. So it was an unfortunate event, but it's not likely to occur again. And NASA's goal is to find 90% of these objects that are 1 kilometer and larger, and track them and make sure that none of them get dangerously close to the Earth. And that is, in fact, the case. We found at least 90% of that population, and none of them represent a near-term threat.
Now, you mentioned that the 1908 Tunguska incident, the object disintegrated in the atmosphere and didn't leave much on the ground, but in the Yucatan of Mexico, people are digging into the Gulf to actually retrieve parts of that asteroid. Is that right?
Yes, that's true. They're doing core samples to bring up parts of the asteroid that actually hit. The crater itself was discovered because they were doing some sampling to see whether there's any oil reserves there that might be lucrative. But in doing so, they actually discovered that there were fragments of this asteroid embedded in the core samples, and they can investigate some of the animals and vegetation that was thriving at that time.
Now, I read an article a few years ago stating that the asteroid probably came in from the southerly direction. They're not positive, but it blasted a huge amount of debris over North America, creating forest fires that perhaps helped to extinguish the Tyrannosaurus rex dinosaur. But it also created forest fires whose ashes are retrievable, that if you dig right under your feet in North America, you might be able to retrieve some of the ashes created by the firestorm initiated by this gigantic impact. Has that theory held up?
Yeah, I think so. It was really quite a hellish environment at the time. As I mentioned, dust and debris was thrown up into the Earth's atmosphere, shutting down much of the sunlight. But when that debris re-entered the Earth's atmosphere, because of the friction of the atmosphere coming back, much of this debris was burning, and the ash contributed to the diminution of the sunlight. And as you say, the ash was spread over much of the North American continent and elsewhere.
Now, I read another theory that's a little bit outlandish, but there were also volcanic eruptions taking place in India around the same time. So some people think, no, it was the volcanoes that wiped out the dinosaurs, not the asteroid. Other physicists have said that the impact in Yucatan was so great that perhaps it sent a shock wave through the Earth and helped to blow out a part of the crust in India, and then helped to create the volcanic eruptions in India. But what are your thoughts about the theory that is volcanoes, or maybe an asteroid, or maybe a 1-2 punch that knocked out the dinosaurs?
I think probably the best explanation is the 1-2 punch. You've got the impact of the asteroid, and at the same time, as you noted, there were substantial volcanic eruptions in the area of India, so that in itself threw debris into the Earth's atmosphere, contributing to the diminution of the sunlight and the chilling of the atmosphere and the killing off of much of the plant life.
Now, I understand that the IMAX film has a simulation using computer special effects, a simulation of a giant impact. Could you explain to us what were the assumptions that went into this hypothetical asteroid impact on the Earth that's profiled in IMAX?
Yeah, this was done by Mark Boslow, computer simulation, as you noted. So the idea is to do simulations that could represent a realistic explosion at the time. So the explosion itself noted that as the object came in to the Earth's atmosphere, you get several effects. You get the shock wave, you get a flash of light and heat, and they arrive at different times because of the difference in the travel time of the light, which is 186,000 miles per second, and the travel time of the shock wave or sound wave, which is more like 400 meters per second. So you get the shock wave and the flash first, and then you get the shock wave which arrives a little bit later. So the idea is to simulate this on computer simulation, supercomputers, computers and hydrocode that is used to simulate nuclear explosions. And in this case, it was used to try and simulate the explosion that took place over the Tunguska region that we talked about, and also the event that took place some 65 million years ago that took out the dinosaurs.
Now, this IMAX simulation, was it as big as the one that knocked out the dinosaurs? And where did it hit? Did it hit a populated area, or was it strictly hypothetical?
Oh, it was just hypothetical, and it was done primarily to replicate the events that took place in 1908 over the Soviet Tunguska region. But the same software and computer code could be used to examine the larger event that took place 65 million years ago, but I don't think that's been done yet.
And was there an estimate of how many deaths might take place if something like that were to happen in a populated area?
If something the size of the event took place 65 million years ago, that would wipe out much of what we know as our current civilization. That would be catastrophic. That would be mostly a planet killer that would take out almost all life forms. It wouldn't completely wipe out life forms, but it would be catastrophic.
Back to Science Fantastic with Professor Michio Kaku. With us today on the line is Dr. Donald Yeomans, author of the book Near-Earth Objects, Finding Them Before They Find Us. He's a principal science advisor for the new IMAX film, watch for it, called Asteroid Hunters. And he, of course, is associated with the famous Jet Propulsion Laboratory in Pasadena, California. Well, we talked about what hit Russia twice in the last 100 years. We talked about what hit Mexico 65 million years ago, perhaps wiping out the dinosaurs. But some people say that, well, within the next decade, we may have to worry about Apophis, an asteroid, perhaps as big as the Rose Bowl, that could do a considerable amount of damage if it were to hit the Earth, and that's a big question mark. So tell us a little bit about near-Earth objects like Apophis.
Well, Apophis is an interesting example of an object that does get very close to the Earth from time to time. And in fact, on April 13th, Friday the 13th, 2029, the object is predicted to pass within 6 Earth radii of the Earth's surface, which is extremely close. And this is an object of about 370 meters in extent. So you've got almost 4 football fields end to end. So it's a very large object. And as you can imagine, the scientific community is excited to bring their telescopes, radar telescopes, infrared telescopes, optical telescopes, every kind of telescope imaginable to bear on this close approach, because it's going to be actually a naked eye object briefly on April 13th, 2029. And as you noted, if when it makes a close approach to the Earth in 2029, it has a remote chance of modifying its orbit so that after 6 more revolutions about the Sun, it will actually impact the Earth on April 13th, 2036, which turns out to be Easter Sunday. So, I mean, that's very unlikely, but it is not completely out of the question as yet.
So in some sense, I guess it's a crapshoot. We have Newton's laws of motion and gravity, but if Apophis were to skim the atmosphere, that's a wild card, right? Newton's laws of motion as applied to friction, and the atmosphere is problematic. Supercomputers have a hard time dealing with things like that. So is it possible that when it skims the atmosphere, that the friction will cause a perturbation to take place so that it might actually hit the Earth on a second pass? Or is that simply a scare story?
Well, the atmosphere wouldn't extend to the close approach distance, but The uncertainties involved with the prediction and the close approach itself does not rule out a possible impact in 2036, although, again, it's very unlikely.
Okay, now, there have been a lot of Hollywood movies, not like the IMAX film that you're associated with, but a lot of Hollywood movies like Armageddon, Deep Impact. Have you seen any of these movies? And if so, how would you critique them, given the fact that, well, it is Hollywood?
Well, we actually provided some inputs for the Deep Impact movie, not for Armageddon, which scientifically was a little bit off the rails, should we say. Both movies came out about the same time in the late 1990s. And both of them cost more to develop than what was being spent on near-Earth object studies at that time. But it did raise interest.
How realistic are some of these movies? You mentioned the fact that Armageddon with Bruce Willis is off the rails, but Deep Impact, perhaps you had some input into these things. But in these movies, of course, we have a fail-safe system, rocket ships, that can intercept these things and perhaps maybe blow them apart. Well, first of all, do we have anything at all, given the fact the space shuttle cannot even go into deep space to intercept these things, and maybe blowing up an asteroid is not the best idea? So what are your thoughts about, well, what do we do about it?
Well, I always say that the three most important things about mitigating a potential impact by a near-Earth asteroid is find them early, and find them early. So if we do find them several years in advance of a potential Earth impact, we can actually send a spacecraft to run into the object to slow it down or speed it up just a bit so that in 10 or 20 years when it was predicted to hit the Earth, it would miss. If you have enough time, again, you could send up a heavy spacecraft and use the gravitational attraction between the spacecraft and the threatening asteroid to move its orbit just a bit so that it would miss. If you didn't have as much time, if you only had a few years to deal with an object that was of considerable size, you could send up a spacecraft with a hydrogen explosive device and set it off the surface of the asteroid that would disrupt the surface material and send a shock wave through it and give it an impulse that would move it just enough to miss the Earth. If you had a time, again, that you could land on the object and bury the explosive device in the asteroid, you could blow it into pieces that would not make it through the Earth's atmosphere. So there's a number of mitigation scenarios that could play out depending on when you found the object to be threatening and how large an object you're dealing with.
Well, the key question is when. It's a matter of time. Let's say, hypothetically, that within a year or so we detect an object that is potentially very dangerous. It could impact the Earth on a matter of, let's say, a few years, within a decade. Are we capable, with our space shuttle, are we capable of even doing any of these acrobatics in outer space, given the fact that for many years we canceled the space shuttle program totally, relying upon the Russians? So what are your thoughts about time frames? I mean, is it realistic that we can get a crash program off the ground to intercept one of these things within a matter of a few years?
Well, a few years, yes. If we're talking about 10 years or so, certainly we could develop a spacecraft, launch a spacecraft toward the asteroid that's coming in and deflect it just enough so that it would miss the Earth, depending on how large it is. And that, of course, is NASA's goal. The Near-Earth Object Program is designed to find 90% or more of the large near-Earth asteroids that could get near the Earth. And now that goal has been adjusted to, let's find 90% of the objects that are 140 meters and larger and see if any of those are on an Earth-threatening trajectory. So far, none of them are.
Well, as you mentioned, the key to the whole puzzle is an early detection system. However, the question is, how many of these near-Earth objects are there out there? Some people say it could measure in the millions, especially if you get down to the size of a football field or even smaller. And how much is Congress taking this seriously in terms of funding an early warning system? What are your thoughts?
Well, initially Congress was not paying attention to this back in the 1990s, but as we get closer and closer to the current time, that more and more there's been more and more interest within Congress, and actually they've been pretty generous in their support of this program. I think it's one of the major concerns the population has for NASA is finding these near-Earth objects before they find us. There's been 24,000 near-Earth objects discovered, mostly in the last few years, with ground-based optical telescopes in Arizona and Hawaii, and also an Earth-orbiting infrared observatory called NEOWISE that's in the so-called L1 point between the Earth and Sun. So that's been observing in the infrared, and the ground-based telescopes are observing in the optical region. We have radar that can observe these things, not for discovery, but to determine their sizes and their shapes and their rotation characteristics. The Arecibo radar in Puerto Rico and the Goldstone facility in Southern California provide radar observations. So there's actually quite an extensive program that's underway to discover and characterize these near-Earth objects that may, at one point, pose a threat.
Now, I understand that when you get smaller and smaller asteroids, they're harder and harder to detect, and there are more and more of them. Some people think that asteroids that as small as, let's say, a tractor-trailer on up, these objects could perhaps number in the millions, and that we're just beginning to track smaller objects, smaller than a football field, smaller than an apartment building, and they catch us off guard. Every once in a while in the news, you hear about an object that just whizzed by the planet Earth, and oops, we were clueless about its existence. So what are your thoughts about being able to track smaller ones the size of, let's say, a truck going up to the size of an apartment building?
Yeah, you make a good point. Because these objects over billions of years run into each other, they fragment and cause smaller and smaller asteroids as they do so. So there's a lot more small ones than there are large ones. For example, we estimate that objects that have a diameter of 10 meters, there's about 10 million of those. Objects that have a diameter of about 30 meters, there's about 1 million of those. As you get to larger and larger objects, there's fewer and fewer of them, fortunately. So, yeah, the object is to find the large ones because those are the ones that could cause problems with cities, impacts. And the small ones we'd like to find, but if we don't find them soon enough, we could use civil defense techniques and sort of evacuate the area under which this object is threatening to detonate.
Now, these small objects numbering in the millions, every once in a while in the press we hear about an object that skims by the planet Earth within the orbit of the moon, and we were clueless. So are these sightings going to be continuous into the next decade? Because, of course, they're more and more difficult to detect. They're small, but they make the evening news. Now that we once in a while can see these things, they catch us off guard. They're not in the books. They're not in this encyclopedia of 24,000 near-Earth objects that you mentioned. So are we going to be continually surprised into the coming years with objects that skim the planet Earth but were missed by radar?
Yes, the short answer is yes. There are so many small objects. 1 meter sized objects, there's 1 billion of those that we haven't even approached the majority of those. But they, of course, will cause the fireballs that you mentioned. And you get the smaller and smaller sizes. The shooting stars are bits of asteroids as well, just the size of a grain of rice or something like that. So as you get the smaller and smaller objects, you get more and more of them. But they have to be on the order of 30 meters, 40 meters, 50 meters before they could cause ground-based damage. And still, there's several 100,000 of those. And so we have our job cut out for us. The searches for these objects will continue with more and more sophisticated instrumentation.
Unfortunately, our time is up. But Dr. Yeomans, thank you so much for being on Science Fantastic.
My pleasure.